I am going to discuss about informed search algorithm in AI. In last video, we have discussed about some of the uninformed search algorithm. So there are PFS, DFS, depth limited, and depth under depth limited. We have one more category: iterative deepening depth limited search algorithm. So these are the examples for uninformed search algorithm. So this is also called as blind search because here there is no any domain specific knowledge about the problem. But in case of informed search, so here we have some cost value, that is heuristic value. Okay, so that is the main difference between informed and uninformed search algorithm. Here we have some information about goal state which helps more efficient searching. Okay, so that is the main objective of this informed search strategies algorithm. So under this category, now we are going to discuss about A star search algorithm. So here we have taken one graph or tree structure. So given this graph, we need to find cost effective path from A to J. So here A is starting node or source node and J is the goal node. So we need to find optimum path or shortest path from starting node A to J. So here A is the source node and J is the goal node. So by using this formula, that is f of n equal to g of n plus h of n, where g of n is the cost of cheapest, that is shortest path from initial state to node n, where h of n, that is called heuristic function, is the cost value from node n to goal state. So by using this formula, we need to find total cost of each node. So here if you see this graph, the numbers written on edges represent the distance between the nodes. For example, from A to F 3, F to H 7, similarly A to B 6. So these are normally called as distance between the nodes, and the numbers written on the nodes represent the heuristic value. For example, A having heuristic value is 10, F is 6, H is 3, and J is 0. J, they don't have any heuristic function because the J is the goal node. So we need to find most cost effective path to reach the goal state from start, that is source node is A. So we need to find optimal path from A to J by using A star algorithm. So in step 1, so we need to start from A. So we can go to B or F. So this is the two path connected with the node A. So by using A star algorithm, that is f of n equal to g of n plus h of n. So either we can go to B or F. So first consider B. So f of B equal to g of B plus h of B. So the value from A to B is 6 plus 8, where 8 is heuristic function or node B. So total value is 14. Similarly, we need to find node F, that is from A to F. So 3 plus 6 equal to 9. So we have to see which is lowest cost value, either F or B, node B. Here, since the node F, the cost function of node F is less than B, so it decides to go to node F from A. So from step 1 we have find that the node from A to F is having lowest cost value. Similarly, from node F we have two subnode either G or H. So similarly we need to find which is having lowest cost value. So first we need to calculate f of G. So f of G equal to, see here, 3 plus 1, because we need to start from starting node A. So A to F plus the value is 3, then from F to G is 1, so 3 plus 1 4 plus 5, where 5 is heuristic function or heuristic cost of node G, so total value is 9. Similarly we need to calculate for node H, its value is 13. So from this we can easily find that f of G is less than H, so we need to go to G. Okay, so when compared to H, the value of G is less, that is 9. So from A to F and F to G, that is the shortest path. So from step 2 we found that the shortest path is A to F, then F to G. Next step is from G we have only one option, that is we need to go to I. There is no other option, so anyway we have to go to I. So from I again there are two ways, either we can go to E or J. Okay. Next step 4. So similarly we need to calculate again from I to E or I to J or I to H. So there are three options is there. Okay, so again similar to previous steps we need to calculate the cost value. So among these three, f of J is having lowest cost function, that is 10. So since f of J is least, so it decides go to node J. So this is the shortest path from A, that is here we have mentioned that A to F, then F to G, G to I and I to J. So here we have mentioned the red line, this is the shortest path. So from starting node A to J, so we have found that this is the shortest path by using A star algorithm. Okay, so in next video